Okay, so what we have here is a graph, and it shows, let's say, along the x-axis we have time in seconds, and then along the y-axis we have distance in meters. So again, remember, this is the x-axis and this is the y-axis. So we have x and we have y. So what we can do is we can see that, so when x is 1, y is equal to 10. When x is 2, y is 10. Okay, when x is 3, y is 20. When x is 3, y is 20. When x is 4, y is, so when x is 4, y is 30. When x is 5, y is 35. Okay, and then when x is 6, y is 0. So when we look along here, we can see that there are different slopes. So for example, from here to here, we have a positive slope. Okay, from here to here, the slope is going to be 0. From here to here, again, we have a positive incline, and then from here to here, the slope is going to be negative. Okay, so it's decreasing. So if we think about from here to here, so we want to try and find out, like, what's the rate of change when we go from here to here. So let's say after 1 second, what's the rate of change here, or what's the slope? So what we need to do is we need to look at, if we remember, the slope is equal to the rise divided by the run. So we need to identify what the rise and run is. So if we think about, so from here to here, this is what's known as the run. And then from here to here, this is what's known as the rise. So what's the run here? So from here to here, the run is equal to 1. And the rise then, from here to here, is equal to 10. So the slope then, the slope in this case is going to be rise over run, which is just going to be 10 divided by 1, which is equal to 10. Okay, so the slope here is 10. So that's the slope, the rate of change. So as we go across here 1, we go up 10. Now if we think about, so from here to here, so we can see that there's no, it's flat. Okay, so there's no rise or there's no run. So therefore the slope here is going to be 0. Now if we think about, let's say, from here to here, so again we mark out, so the run is going to be from here to here. Okay, so that's going to be the run, and then the rise is going to be from here to here. Okay, so this is the run, and then this is the rise. So this line here, and this line is the run. So the run, if we think about what that is, so we're going from 2 up to 5. So 2 to 5, that's 1, 2, 3. So the run is 3. And the rise, it's going up. So it's going, each box is 10, or each box is 5. So it's 5, 10, 15, 20, 25, 30. So the rise in this case is equal to 30. So the run is 3 and the rise is 30. So again, the slope in this case, so m is going to be, So the slope in this case is going to be m is going to be equal to the rise, which is 30, divided by the run, which is 3. So therefore the slope in this case is 10. So the slope here is 10. And then if we look from here to here, so again if we look from here to here, and I'll just do this in a different color, call it green color. So let's say, so this here is going to be the rise, okay, from there to there, and then the run is going to be from here to here. So if we think about, so the run is going to be equal to, it's equal to 1. So the difference between 5 and 6 is 1. And then the rise then, it's actually decreasing. Okay, so you're going from, so it's decreasing down here. So the rise is 5, 10, 15, 20, 25, 30, 35, 40. So it's actually 40. But it's negative 40 because it's decreasing. You're going from here, you're starting at 40 and you're going right down to 0. So it's negative 40. So therefore the slope in this case, so m is going to be equal to the rise, which is negative 40, divided by the run, which is 1, and then therefore the slope is just going to be equal to negative 40. So we can see here that the slope is negative 40. So again, this is just a way that we can look at a graph and we can identify the slope from the graph, from the information that's given on the graph, without anything else. We just need to be able to identify the rise and the run. So we can see there the run and the rise, it's going to form a right angled triangle like so. The run is along the bottom, the rise is the run is the x value, the change in x, and then the rise is the change in y. And again, if we have like a horizontal line like this, it's going to have 0 slope. There's no rise or run. And the same here, we can see that this slope here, so this line and this line has the same rate of change or the same slope. So hopefully that makes sense. And this is basically how you can use a graph to identify and read off the slope.